Hey everyone, this is Matt with Learn Everything About Design, and today in Plasticity we're going to make another 3D printed print-in-place fidget toy. So these are good things that we can practice modeling because one, they let us understand how we can make sort of numerically controlled features, so working within some tight tolerance values. And it's also just good practice. They're fun to make and lots of people enjoy playing with them. So to get started, we're going to begin by deleting the cube. We're going to hit the forward slash to zoom in, and then we're going to double check our units. It's always a good idea to double check your grid and unit settings, especially I find that when I'm designing for 3D printing, I really need a good sort of reference for the size and the area that I'm working in. So 250 grid size, 25 millimeters for accent lines, and that's generally where I stay. It's my printer's a little bit bigger than this, but this gives me a good idea. And the grid lines every 25 millimeters give me a rough idea of about an inch, so it's a good idea for scale. So what we're going to be doing is making a sort of a fidget spinner toy, but we're going to use these concentric rings. And there's a couple ways that we can do this. We're going to use some basic tools. Again, we're going to be looking at just using the circle tool. We're also going to talk about offsetting. We're going to look at actually using the trim tool. And in terms of actually modeling it, again, it's going to be very basic. So you should be able to follow along even if you're new to plasticity. But if you are brand new, I do suggest checking out our starting guide so we could do a bit more on the user interface overview. So make sure that you do check out that content as well. And also a quick reminder, if you are looking to purchase, we are an affiliate, so the code LEAD10 at checkout will save you 10% on the Indie or the Studio license. So to get started, we want to go to a front view. This can be done by clicking on the cube, or if you have a numpad, then you can use 1 on the numpad. We're going to begin first by using the center diameter circle, and this circle is going to be the outside diameter of whatever it is we're building. So think about the size that you want, the overall height, and the diameter. So what I'm going to do is I'm going to hit tab and then hit 50 millimeters. We'll hit enter. So this will be the outside of our object. The second thing that we're going to do, you can hit forward slash to zoom to fit if you want. We're going to go to a rectangle. So we're going to find the corner rectangle, hold down the left mouse button, and then we'll grab the center option. We're going to go from the origin, and we're going to basically just make a rectangle that is the height that we want. I don't really care about the width because the width is going to end at our circle, but the height is what we want to deal with here. So I'm going to make it fairly small just so it prints a little bit quicker. I'll give this a value just because we can, but we're going to tab over to the next one, and I'll just do 12 millimeters and hit enter. So it's going to be roughly the size of a ring. So what this allows us to do is have some reference curves that we can use as a trim, but we're not quite done yet. So the next thing that we need to think about is going to be making 3 concentric rings. Now, the reason that we're using a circle here is because we want this thing to be able to rotate as in a sort of this hemisphere. We want it to be able to spin freely in all directions. And the reason that we're using the circle is because that'll allow that to happen and all the pieces will stay locked together. If you don't need it to spin in all directions, if you only need it to sort of spin around in itself, then you can just use anything that will be able to lock it in. So you could use a V, for example, and then you could have those V's lock it in. This will make a bit more sense once we actually create it, but this is the reason that we're doing it. So now that we've got the external circle and we've got the top and the bottom edges, we want to start to make other concentric circles. And this is where we need to start to think about distance values. Now, if we just use offset, for example, if you select this and use offset, we can do this by hitting O on the keyboard, or you can select offset curve down here. This will allow us to pull this in a specified amount. So in this case, I'm going to say, let's say -4 millimeters. It's probably going to be fairly thick, but this is going to be the cross section that we're working with. When we're doing 3D print in place parts, the general number that we work with is 0.4 millimeters. So you can make things tighter than this. You can also make things looser than this. And what we're going to do is offset this curve. We're going to go -0.4. So basically what we have, we're going to hit enter again. Basically what we have is this is a gap between this piece and whatever the next piece is going to be. So we're going to take this one, once again offset. We'll do the same number, -4 millimeters. So we've got this profile and this profile. These are going to be the two that we're revolving. We're going to do one more. So we'll take this curve, offset. We're going to do minus 0.4. And then while it's still selected, we'll do offset again, and we'll do minus 4 millimeters. The inside one can be a vertical line, which we'll get to in a little bit, but the basic that we have here, the basic sort of structure, is we've got these three profiles. You are not required to trim these. You can leave them as is and be totally fine. But if you want to clean up what we're working on, then trimming can be a good way to do that. We can use a trim tool. It's T on the keyboard, but if you want to just grab it here, we can box select, which is a really quick way that we can do this. And I actually don't need anything over here. I only need these three regions. And then while we start on the trim tool, I'm going to zoom in and I'm going to select these. Let me go back to a front view. And I'll hit T to trim again. And then right click to accept. So now we got these three profiles. We don't have to join them together if we don't want to, but basically this is what we're doing. On the inside, I don't actually need this to be a curve. I'm going to make it straight, so I'll hit delete. And I'll use my line tool, and it should just be a vertical line. Something else to consider, if you want to build this in a different way and you want to use the same values every time, we have the option to duplicate that curve. So for example, if I do Shift D, I can duplicate it. And whenever we do this, what we want to do is we want to move it using the freestyle option. So that's F on the keyboard. And the reason for that is when we hit freestyle, we select the point that we want to start from and the point that we want to go to. All right, so we can right click and put it there. And then we can move it. In this case, we'll use G on the keyboard or select move. And again, we can do freestyle if we want, but really all we need to do is move in the X a distance of 0.4 millimeters, and that'll give us the precise gap. So the reason this is important is because if we duplicate it again, and we use freestyle, again, F on the keyboard, I can pick this as my starting point, and this is my ending point, and that's going to preserve that 0.4 millimeter gap. So while we can use dimensions for certain types of things in plasticity, we're not really building out fully defined sketches like we would in another CAD program. So when we're trying to stick with this sort of precision of needing a 0.4 millimeter gap, then we need to really think about how we're doing that, whether it's an offset curve, whether it's duplicating and moving with freestyle. Both of those options are perfectly fine. But now that we have this, I'm going to go ahead and select each of these profiles. We're going to select revolve, and I'm going to select Z twice, and then right click to accept. In case I want to keep these curves, I'm going to leave them here, but I'm going to select them all and then just hit the eyeball icon on one of them, and that'll hide them all, or you can use H. All right, so now that we've got these three rings, we could print them as is and spin them around, but generally you want some sort of texture on the outside. We could go into a big video on adding certain features to the outside. You can add text and so on. At the end of this, what we're going to do is we're just going to use dimples. So it's kind of like a golf ball. This is a really easy way to do this by using the sphere tool. But first, let me just go over the Deform tool because it's a new tool in plasticity. We've talked about it in the What's New video, but if you want to use it in a case like this, let's talk about how to do it. So the first thing that we would do is we would select the outside face. We would hit F on the keyboard to find and start to type in unwrap. When we unwrap, what's going to happen is now we've basically got this outside face as a flat plane. The reason that's important is because now we can add text or whatever pattern we want to it, and then we can go back and we can deform it around our object. So to do this, I'm going to hide all of these other objects. I'm going to select this plane and hit space on the keyboard. What this does is it creates a temporary construction plane. The reason that this is nice is because now we've got the outside profile that we can use. So if I wanted to, say, draw a line, and I want to make this line at 45 degrees. So I'm going to hit tab, 45 degrees, and hit enter. The line is currently extending below, you can see here. So if I use the trim tool, nothing happens because this horizontal section here, even though we can select it, it's part of a profile, and it can't really be used as a trim. So I'm going to hit escape. What we can do is we can bring that in a couple different ways. I generally just use duplicate because it's a shortcut key that's really easy to do in the left hand. So I just do Shift D and then right click to accept it. So now we should have the ability to trim this at the end. If you don't, Part of the reason for that is because we may need to make sure that we're in plane. So make sure that you select the edge, Shift D. Let's go ahead and do this again. We're going to go back to this construction plane. So I'm going to hit spacebar. And you can see what happened before I duplicated the sheet instead of actually duplicating the edge. So if you've got all your selection filters on, this happens to me all the time, just make sure that you are selecting the proper thing. Once we have the edge selected, we should be able to trim it, right click to accept, and then I can delete that edge. I don't really need it anymore. So what we're going to do is I'm just going to go through a quick example, and we are going to duplicate this. So again, Shift D, or if you like to use the buttons, you can click here. We're going to go in the X direction 2 millimeters and hit enter. And basically what we have is we've got this little profile here. So I'm going to use my line tool. I'm going to close it off on the top, right click to accept. We use the line tool again. I do strongly suggest that you get comfortable with shortcut keys. This will save you a whole lot of time rather than moving all the way over here for the line tool. Shift and A, most of the common shortcut keys are going to be left-hand shortcut keys, which is really nice. So Shift and A for the line tool, Shift and R to repeat the last command. And then we're going to join these together. J on the keyboard to join them together. With that one curve selected, now we can either do a rectangular array. We can go in this direction. I'm going to zoom out a bit. And basically what I want to do is come all the way to the end. And then we can increase the number if we want to. It doesn't have to be perfect, but this is going to get us close. So next, we want to select all of those profiles. So I'm going to go to my face selection mode. This will simplify it a bit. You can either use these little sections here, or you can use the inside, the larger sections, and we can either add to it or cut away from our object. But basically what we're going to do is we're going to build a solid part, basically a solid version. So I'm going to just go ahead and grab those. This will at least highlight how we're going to do it. And then we'll go in, let's say, a distance of 1 millimeter. That'd be okay. So now we want to hide all the curves. Delete them if you want. I'm going to delete them, but you can hide all the curves. We're going to bring back the outside shape. So the largest one here, that's the one that we flattened. And then we're going to deform. So select all the objects you want to deform. And F, start to type in deform. Then we need our reference face. This is going to be this surface, and then our target face. When we do this, you can see that now it's wrapped around the outside. This does not have a Boolean option built into it, at least yet. So we have to be careful with the distances that we're using. And what I mean by that is we extruded this a 0.5 millimeter, and we went from that offset face, or the unwrapped face, and we pushed it down in the negative Z direction. So in that orientation, these are going to go into our part, which is what we want. If we happen to do this the other way, and we extruded them up in the positive Z direction, then they would be coming out of the part. All right, so right click to accept. I'm going to go back to my all selection. And now if we want to remove those, we select the original object, Q for Boolean, or you can select it down here if you wish, and then the tools that we're going to remove. So I'm going to start selecting these and working my way around. So if you select a tool, you'll notice that it's giving me a warning, the Boolean failed. Now, this happens with the Deform tool, and the reason for this is because, again, those offsets, it's leaving a paper-thin section there. So one way to get around this is to take all of these and scale them up. So I'm going to hit S twice and scale them up just slightly so that they are scaling from the origin and they're scaling outward. You can see they don't wrap all the way around because those large triangles I left on the outside. I'm going to hide the sheet as well. All right, so now if we do Q and then select our target bodies, you have to hold down Shift and work your way around. You can select them in the outliner as well, but I'm just going to work my way around here. We'll be able to select through because we've already selected that main body as the original, the target, and then we can right click. So what that did was scaling them allowed them to go all the way to the top and the bottom. You can see it left a little bit of a sliver there, so we would likely want to scale them up a bit more. You can delete those if you want by hitting delete on the keyboard and cleaning that up, but it's just easier to scale it. All right, so let's get off the construction plane, Control Z to undo, I'm going to bring back all those bodies. And then with all of them selected, what I'm going to do is hit Scale, Z. So I'm only scaling in the Z direction. And then I'm going to scale them a bit larger than my part. All right, so Q again. And then for all the tools, we can just hold down Shift and box select. And now you can see that's a bit cleaner. All right, so I'm going to go ahead and I'm going to print that. And on the inside ones, we'll use the dimple method. So that way we can see it. All right, so basically what we're going to do is start with a sphere, draw it at the center, pick whatever size you want, right click to accept. We're going to go to a front view, / to fit the screen, the selected object, and zoom out a bit. Then we're going to move it. So G, and move it out here. And then we want to figure out the overlap. All right, so we can still see the depth of the profile here. So just pick a size where you want it. And then what we can do is do, again, Boolean. So Q on the keyboard, remove that, and we'll select this face, and F to search, array, and we'll do a radial array of the face. And if this doesn't work, this does have a tendency to fail if we do it right on this edge. So if you do have a problem with that, we can Control Z to undo, and we can do a radial array of the sphere. And let's maybe increase this so they're a bit closer. And then we can remove it with Boolean. So again, Q. This time we can't box select because I got that other revolve shown, so I need to hide that. And we'll just hold down Shift and box select. And now we've got all these little dimples in it. And you can do the same thing to the inside. And again, we can use the dimple method if you want. You can go ahead and use the deform method, whatever you see fit. And we're just going to G and X and move this. Going to make a bit of a deeper dimple. Circular array, reduce the number because they're overlapping too much. Q, right click to accept. You can see it's probably a bit too much, but that's okay. All right, so now we've got these three parts. I'm going to turn off X-ray, and we can print them as is. They'll print in place. They will be permanently locked together because of the spherical section, the arcs that we have on the outside. They won't be able to come apart, but they'll be able to spin freely. So let's go ahead and print this version of it, and let's see what it looks like. To do this, all we really need to do is go to File, Export. We can pick where we want to save it. So I'm going to just create a new folder, and I'll just call this Print in Place Ring. And I'll toss it in there. STL, OBJ really shouldn't matter. I'm just going to call this my PIP ring. I need to take a close look at the tessellations. If I print out this with the density of 0.5, it's going to be very tessellated. I'm going to see these divisions here. So I'm going to kick this all the way up and just make sure that it does have enough triangles. Then we'll right click or click OK. And then I'm going to bring it into my print slicer. So I use Creality Print. I like the older version of Creality Print for my own personal use. Let's go ahead and bring it over to the correct screen, and we'll open the model. So I need to search for it first. All right. So pretty straightforward. No supports needed. We'll slice it. I'm going to play a little bit of 3D printer filament chicken. I don't have much left on the machine, but I think it might work. So I'm going to export it, toss it in my jump drive, and then let's print it out, see what it looks like. So it printed just fine. I had enough material. I could probably print a second one. It doesn't actually take that much material because I used an infill. And the gap of 0.4 is enough to keep it loose so that it can move freely. You could try to tighten it to 0.2 and see if that would work on your printer. Sometimes you need to actually force it to break loose, but you can see that it works fine. It spins around. And this is a great design because it's really easy to do, but you can configure it and change it to have all sorts of different features. You can put text on the outside. You can put little features like these ridges or dimples, and just play around with it and make it unique and make it your own. I've printed a ton of these different sort of variations and different heights and thicknesses. And I think overall, it's a really easy design that looks way more complex than it actually is. So hopefully you found this fun and easy enough to follow. If you have any other questions, then please leave a comment and let me know. I do have plenty more 3D printing content for Plasticity planned as soon as I can get to them, and I'll start uploading that content for you. So as always, thanks for watching, and we'll see you in the next one.